Good day, everyone. Welcome back to the training session. And today we are going to part 2 of the interpretation and reporting of our results. All right. I want you to listen carefully and follow me to the interpretation. All right. Part 2. Interpretation and reporting of the output of t-test analysis. We are dealing with t-test analysis, and we have different type of t-tests. You take them one after the other. I've already explained in our previous training. The first one we are going to look at is one sample t-test. One sample t-test. And the t-test, one sample means that, like, if you take age in a coding, you know that age has 3 categories. We have from 9 to 10, 11 to 12, 13 to 14. Now we want to look at the mean of that age. The one within the 9 to 10, that age is a one variable that we enter. That's why we call it one sample t-test. Now, when you run it, this is what you will get. You will get these 3 tables. You get one sample t-test, one sample t-test, one sample t-test, one sample t-test analysis. All right. Now, the first table you see here contains your descriptive. That is the number of observation, this N, the mean, the standard deviation, and standard error. You see now, the number that we observe is still the same thing. We see the same thing, and we still have it as 60, our mean, our standard deviation. That is why it's a descriptive statistics. Now, the t-test, these are t-tests. Look at it here, t, age. And under that t here, we have 17.195. And df, we have 59. And significant, two-take, we have 0.00. There we have mean difference, we have lower, we have upper. Now, I want us to underline this. Because that is where we are going to work. Now, from this place now, the yellow color, we have t-test, we have degree of freedom, and we have a significant level. Yes, that's what we have there. And from this place now, we can say that our result is statistically significant. Why? Because this 0.00 is less than 0.05. If you remember, that is either use 0.05 or 0.01, and here now today we have 0.00, less than 0.05. And anytime you have number here less than the 0.05, we say the result is statistically significant. And the t you see here, we always call it calculated t-test. Calculated t-test, yeah, because there is a table that we can use to check between calculated and tabulated. If you have 4-figure table and we check under t-test analysis, you will see the one you check there under degree of freedom of 59, you will see it as a what? Tabulated t-test. But you don't need to bother yourself. Once you have your t-test here, you have your degree of freedom, and majorly the significant level, which is less than 0.0%, is statistically significant. Now let's move down to what we have here too. Now for the next one, which is gender, you know we have gender, like I said, we have 3 tables. We have age, gender, and class. For gender too, we have our mean, we have our number of observation, the mean, the standard deviation, and standard error mean. And let's move down to our t-test. We have our t-test here like this. That's our t-test that we want to consider, and a significant level that we want to consider. All right. Now, from what we have here now, under gender, our t-test is 24.303. Our degree of freedom is 59, like what we have, since it is 60 and we are going to have 59 because it's just 1, just deduct 1 from 8. As significant level is telling us that we have 0.000. We have number after that 0, but because we've restricted, okay, maybe 3 after 3 decimal places, we have number after it because the place cannot contain it down. And the one that we are interested in is 0.05, and we have this one. You don't need to stress ourselves. It's less than that. Therefore, we call the gender 2 is statistically significant. Okay. Now let's move. That is how you write it in the t-test. You can write it here and say from the table above, the gender is statistically significant with T calculated which equals to 24.303 and degree of significant level P less than 0.05. Therefore, the significant level. Just tell us what you have there. That's all. That's how to interpret. Okay. Now let's move to the class. Okay, I put to there. Now that's for one sample t-test. For independent sample t-test, independent sample t-test, independent sample t-test. They don't want to depend on anything. Now the group statistics, the first table is group statistics, and I pick gender, the gender and the class, the gender and the class. Okay, now under that one, under this independent sample t-test, you know how do we do that one? You know, you go to your value, you go to this place, this your graph, you click on it like this, and you've done that one before. This is now t-test. That's compare means independent t-test. See, this independent t-test, and that's the value you will get. All right. Okay, let's move down to our interpretation. Now this is the value you will get, telling us that the male. Now I group independent the gender and the age, then the gender and the class. Now we have 24, and that's the mean and the number of observation and the mean. This is what we have, the standard deviation and the standard error mean. Now let's move down to our t-test. Now under this now, because it's independent sample t-test, we have two things that we need to look at here. Here we have equal variance assumed, equal variance not assumed, and here test for equality of means, Leibniz test for equality of variance. That's what we have for F statistics and significant. Now the t-test for equalities of mean, you know we are comparing means, and that is what we have from this line down. We have T, we have degree of freedom, significant, two-tailed mean difference, standard error, mean lower, and the upper one. Now under the two options we have here, equal variance assumed and equal variance not assumed. You don't need to assume. Therefore, we pick equal variance not assumed. Our t-test under the age of independent sample t-test is this. That's it. Now, these are degree of freedom, DF, and our significant level. Now from this place now, you can categorically tell me that this is not statistically significant with combination of the age and the gender. You see now, this place is 0.275, which is far beyond 0.05. If you check your 4-figure table under degree of freedom of, let's say, 50, or let's say 50, but by the time you approximate it, that's 50. By the time you approximate, you get 50. You check under 50, you discover that what you are going to get there is going to be more than 1.105. And as I said, once you have a significant level here, you can be able to interpret your results. Say, it is not statistically significant. Is that taken now? Now let's go to class. Now look at class 2. Equal variance assumed, equal variance not assumed. Can you see it now? Okay. And the t-test we have there too, we have this. We have the which is equal variance assumed. Now you go to equal variance not assumed, which is this, together to your significant level. Let me just paint it so that to be sure that that's what we are dealing with. Now here too we have significant level. Here we have 0.167. 0.167. It's telling us it's more than 0.05. 0.05. And once it's more than 0.05, it's telling me that what? It is not statistically significant. The combination of that class and gender is not statistically significant. Is that taken? Alright, let's move further. Paired sample t-test. That's the third one. Paired sample t-test. And I have this. I paired mathematical achievement test and English achievement test for the first one. Paired 1, you see paired 1. Paired 2, mathematical achievement test and gender. Paired 3, English achievement test and gender. And these are normal number of observations, 60, 60, 60. Your own can be more than that. And these are significant level for this peer sample correlation. So these are correlation value. These are correlation of 0.091 minus 0.272 minus 0.54. That's what we have. And from this place now, although we are not dealing with correlation, when we get to correlation, let us know that. Let's go to our t-test now. T-test for paired. Alright. Now, paired 1, mathematics achievement test and English achievement test. This is what I have. Is that taken? Now, you come back here. This one is standard deviation, the mean, and the standard error mean. The lower, this is the confidence of interval of the difference. These are t-tests, and these are degree of freedom and sigma of duty. Now you come back to this place, the paired one. You see, I have that. Let me paint it, okay, so that you can see what we are doing. Okay, now the third one, you can see what I'm doing. Okay, all right. Now look at this. Look at this. Paired 1, mathematics and science. Look at the t-test there. Look at the t-test. Minus 0.707. And look at the degree of freedom. The degree of freedom is 59. Yes, because we paired it. Row minus column, then we have 59. Now once we have done that, now come back to significant level, which is 0.783. Look at this 0.873, which is greater than 0.75. And what this one is greater than, this means that there is no significant difference, there is no significant relationship between mathematical achievement test and English achievement test. Now we come back to this. Pair 2, mathematics achievement test and gender. Now with what I have here, I have my t-test to be 33.739, degree of freedom 59, and significant level, which is 0.00. It shows that this one, there is a statistical significance between mathematical achievement test and gender. Okay, and if we move down to English achievement test and gender as well, we have this 46.640 and degree of freedom 59 and significant level 0.000, which is what? Less than 0.05. And what is less than, you show that English achievement test and gender, they are statistically significant. The mean you compare are statistically significant because we are comparing mean. But this one we pair them together as an individual. We pair two variables together, and that is the result we are getting. You can now conclude from this place that the performance of students and the performance of student mathematics and in English during this one are not statistically significant. But based on their gender and the mathematics are more statistically significant, based on their gender and their English achievement, they are statistically significant. Is that taken? All right. right? That is where we will end this part 2 of interpreting and reporting of our SPSS results. Thank you.